Hi everyone, welcome back. So in this video, we will discuss about modules and kernel build system. So let's get started. So this is the content that I will be discussing in this video. We will discuss about modules, then we will discuss how to build, install and load a module. At the end, we will discuss about exported symbols. So the whole kernel runs in a single address space. So in that sense, we say that kernel is a monolithic in nature, but kernel provides this facility that when kernel is already running, at that time, we can insert or remove some part of the code. That code we call it as a kernel module. So it contains everything that kernel needs. So we can say that it contains related methods or subroutines. It contains data, and it also contains a well-defined entry and exit point inside the kernel image. So we will see how we have this entry and exit points. So this is a sample code for a module. So if you see here, this is the way we define a module. So if you see here, like this is a init function. So whenever we load a module, this init function will run automatically. So here in the init function, I am just printing a statement, but in actual sense, it does some initialization in the kernel depending on the requirement of the module. Similarly, there is a exit function. So whenever we remove a module from the kernel, at that time this exit function will be called. So mostly the exit function undo whatever init function have done. So like we have during the execution, we have opened some files and we have allocated some memories. So in the exit function, because we are removing a module, we have to close those files and we have to deallocate the memory that we have allocated for the execution. And we have other macros also. So this is a type of license of a module. So there are some developers, they want that their module should be used by GPL compilance code. So at that time we can define GPL or non-GPL, and this is the author of the module, whoever has built the module, and this is to add some description for a particular module. So this is just a simple uh, module code. And for building a module, this include is important. We have to include this module.h file here. So let's now deep dive how we can build this sample code of module, and after that how we can load it into the running kernel. So building a module requires the kernel build system. So kernel build system is actually built on two things. One is makefile and one is kconfig file. So we have to define the rules in the makefile, how to build the kernel, and uh, whatever configurations we have for kernel, we can define in the kconfig file. So I will describe more about these things in coming slides. So let's now learn more about kconfig file. So if you see here, if we are creating a new kconfig file for our module, then at that time for the parent directory, we have to source this kconfig file, because KBuild system doesn't know that you have created a new kconfig file. So in the like if we have created a directory where we are writing our code, so in that directory we have to define a new kconfig file. So the parent doesn't know you have created a new directory and you have a new kconfig file. So in the parent, we have to source this file first. Now let's see what is the content of kconfig file. So to define a single configuration, this is a sample code. So if you see here, we have to write config, then the configuration name, and this is a little description, and it tells the state of it. Like try state means this configuration can be built as a module, or it can be inside a kernel, or we don't we or it can be like we do not need to build this module. So default is n. Here default n means we don't have to build this module. Whatever modules are dependent on this configuration, we don't have to build those modules. So I think it is not very clear, but yeah, in coming slides it will be more clear. Here I am just trying to tell the different fields of a configuration option. So if you see here, this is a help. So in the help section, we describe for what this configuration is used. So here you can describe how this configuration will help in the building of a module. So here we also have keyword depends. So if this configuration is depending on some other configuration, so uh, we have assume that we have some other configurations depending on this, like we want to enable this configuration based on the other configuration like fish tank. So that means if the fish tank is already enabled, then only we have to enable the fishing pole. Okay, so like in this way we can tell that until this is not enabled, you don't have to enable this one. So that's why we tell that based on the depends keyword. So depends can be appended, like it can have multiple condition using this and operator. And the select keyword tells that whenever this configuration is enable, at that time we have to also enable this bat configuration. So it is saying that, it is forcefully saying that if bat is there, you have to enable the bat. So this is not a good way to use select, because it doesn't check for other things, it directly enable some other configuration based on the previous configuration. So we generally don't use select keyword, we generally use depends whenever required. So here the type of a configuration can be of different type. This is a tri-state, it can be bool, it can be string, it can be int also, but mostly we use tri-state and bool. And in this we can have a if condition also. So like here also we are saying that if ocean is already enabled, then only we have to enable the this particular configuration. So this is a sample configuration file. So here if you see here, like I have defined here two configurations, ocean and fishing pole. So when this file kconfig file will be built inside KBuild system, at that time we can access this configuration in form of this string config underscore ocean. So by default it will detect as a configuration. So here you see that this is a way we define. So we can define multiple configuration. Here we have to put default, and in the help section we can explain what ocean configuration is doing. And all these all those fields that we have already discussed, in this manner we can put it in a particular configuration. So here I am putting select also just for example. This is depend, this is default, this is the type of the configuration, and this is also containing the if condition. So in this example I have put every keyword used in the kconfig file just for the sake of example. So it may not make the sense, but I have put it for just to how to put all these things in a single configuration. So okay, now we have set up our configuration file, but as we have seen that we need two things here to build a module. So we need kconfig and we need makefile. So we have completed this one. Let's now see how to build, how to set up the makefile. So this is a way where we can set like we can update the makefile. So in the kernel we already have makefiles for already compiled kernel. So if our module is already inside the source tree of original kernel, at that time we don't need to create a new makefile. We can just update this entry inside the makefile. We will see the example in coming slides, so it will be much clear. So now you see here, if if this module is dependent on this configuration, then in this way we can define. So this is saying that if this configuration is on it, then only you have to build this module, otherwise you don't have to build the module. If this configuration is not dependent, then you can directly define in this way. Yeah, and so it will go to inside this directory. Like we have created new directory. Inside this directory we can say how we have to make a kernel object. So this is a kernel object. So here we are saying we already have a kernel object image. Again, append. This plus tells that append this module also inside a kernel image in the form of a module. This m tells that it is a module. So if you see here, like if your module, like if this kernel object is dependent on other objects, then in this manner we can define here like my module, then objs, and then we have to define in this way. So it will take these kernel objects or modules and build this my module. So let's assume that our module is not inside a kernel source tree, and kernel source tree means we have the whole kernel defined in a particular structure. So and we are going inside particular directory, and we are building our module or creating our module inside that, then we say that we are living in a source tree. If our module is not present in the inside the uh, code structure of already built kernel, at that time we have to define the module in this way. So here if you see, there is a difference. Like we are here, we are saying that dot and is equal to, here if you see, we are saying plus is equal to. So plus means we are just appending, because we already have the code inside the source tree, because we have created the files in the source tree. Here we are saying the files are not inside source tree, files are somewhere else. So similarly, if our module depends on other things, then we can define in this way. So this is a uh, sample make file. So if you see here, this is a whole make file, and in this way we tell kernel that will this module. So if you see here, this is a make command. So this is a path where we are saying that my module code is inside this path. So go there and build in the present working directory. So, and if you see here, this is a absolute address. So whenever we are building a kernel, it will take the address from the uh, mostly it's in the root directory. So from there it will go and build the whole build our module and insert inside the running kernel. So this m tells that we are building a module from a other location, not inside the kernel source tree. Okay, so here we have set up like make file, and we have set up kconfig file. So these two files are now available to us for our module. After these things are available, we can run this. So like if our code is, and again we have two conditions. So if our code is inside the source tree, then we don't have to specify the path to build it. Directly we can say that make modules. So it will build the kernel, and it will check what are the new files, and it will make those kernel objects directly. But if our code module code is outside kernel source tree, at that time we have to run this command, uh, as we have already seen uh, in the make file. So now from this make command, our modules are generated. Modules means ko file. Like, so our generated modules will be inside some some location, something like that. Mostly our build kernel modules are inside this path. So it is little confusing that we are in the make file we are saying we have to generate .o file, but here we are saying it is a ko file. So yeah, so it is little confusing, but ultimately we are generating the kernel object file. So that's why we have the ko extension at the end. So once our modules are ready, we can install them inside kernel with the help of this command. So if we again we have the two conditions. So if it's already in the source tree, then we can run this make modules install command. If it's outside, then at that time again we have to specify the path from where our kernel has to take the module for installing. So let's now understand that there are assume that we have some like few modules, so maybe m1, and it depends on m2, m3, and it depends m4. Okay, so if we know that our module, maybe our module is m1 and it depends on m2 or m3, then at that time we have to build the dependency so that kernel can build whole all the modules required for our module to run properly. So at that time like we can run this command dap mode, so it will build the dependency tree for the kernel. When kernel will build the modules, it will know that this module depends on other module, and accordingly it will build the module. So it will build first m1, then it knows that it depends on m2 and m3. Oh sorry, so first it will check that there is a dependency, so it will first build m4, then it will build m2, then it will build m3, then at the end when all the dependencies are built, then at that time it will build m1. So this command is just to check the new dependencies only, so, and we don't have to build for already uh, already build code. And these dependencies we are storing in this file path. So modules dot dep is a file where we store all these things. So okay, so here after running this command make module install, it will be like it will be created on the uh, like it will install the modules. So now it's inside the kernel, but we have to insert it into the running kernel. At that time we have to run this command to load in the kernel. So this is ins mode. Ins mode means insert the module. So we have to write ins mode and the module name, and module name is stored in the ko file extension. And if we want to remove the ko file kernel module, then at that time we can write rm mode and then the module name. So these two commands, when we run the commands, uh, it will not check the dependencies. So if we want to make sure that whatever all the dependent modules are also built, at that time we have to run this mod probe. So it does check the dependencies, and accordingly it builds the modules required for the dependency. And this is the opposite, like we have to specify -r to remove the module. And this is important, like module parameters. So if I while I am inserting a module inside a kernel, so if I want to say I want to give some parameters like k1 or k2, or I want to give some value like 3 here is equal to 4. So these values will go inside kernel, and in our module code, whatever, like here we have seen some module code. So here in this in these functions we can use those variables as a global variable inside this module. So so whatever parameters we are specifying while inserting a module, these will be available inside module as a global variables. We will know more about it in next slide. So if you want to see that our kernel module is inserted or not in the running kernel, at that time you can run this ls mode. So ls mode means list the modules. So here if you see, these are the different kind of modules, and this is the size of a module, and this used by field is just to tell how many instances of this module is being used inside a kernel at that particular time, and it contains that little description of a module. So let's see how this KBuild system is integrated in the kernel. So I will show you some examples of makefile and how makefiles and the kconfig file work. So if you see here, I am here in this directory under drivers. So if you go at the end, you will see a makefile and kconfig file. So let's open the kconfig file. So if you see here, here we are sourcing the kconfig file of all the directories the inside the drivers directory, because in the drivers directory we have multiple directories like uh, SL, accessibility, ACPI. So for all these files, we have again we have this kconfig file. So we are sourcing that, and we will see the actual kconfig file in so if you see here, like this is a make file that for the drivers directory. So if you see, like in this way we are telling you have to build this directory, and you if you see here, like this object is dependent on this configuration that we have already defined in the kconfig file. So if you go into this kconfig file, uh, you will find, if you follow this kconfig files, you will find this configuration there, and based on that we are making some decisions. So here are the different, the same way we have seen in our example. So let's go and see the last level k config file. So let me say, so let's say we are going in in the USB directory. Okay, so in the USB directory also we have kconfig file and make file. So in this way kernel knows that from there I have to go inside and then go inside, then go inside. So in this way kernel build the whole kernel. So so if you see here, this is a way we define a kconfig file. So if you can see here, this is a live code of kernel. I think it is the latest version. So if you say, this is a directory of Torvalds, Linus Torvald, who is founder of Linux kernel. So this is the latest. We are seeing the latest file in the kernel. So if you see here, like the same way we discussed in our previous slides, the same way they are defining different config file configurations, and they are also sourcing the kconfig from other files so that they can use inside this kconfig. Now let's go to the make file. So if you see here, the same again. So in this way we know that kconfig uh, kconfig and make file defines how kernel will be built and how modules will be built, and after that we insert them. So now let's discuss more about module parameters. So if you see the example of this code, so if you see here we are defining the module parameters. So this is just syntax how we can define a module parameter. So first one is the name of the parameter, second one is the type of the parameter, and third one is the permissions to do operations on that parameter. And in the sysapps file system, we will discuss about sysapps file system in the next video. So in this way, we are defining different module parameters, and this is a sample module code. So if you see here, like in this line, when I am trying to insert the module, at that time I am providing those values to different variables, and these values will be used as a global values inside the driver. So if you see, like here we are printing those values. So when uh, we are removing, like we are inserting, this init function will be called. So if you see, these values are printed here, and those values are taken from this when we are inserting. And like module parameters are not only this single type, we can have multiple types. So to define multiple modules, we can like if you want to define a module parameter that is string, then this is a function we have to define. If we want to allocate a array to a particular module parameter, then in this way we have to define this is the name of the parameter, this is the type of the parameter, and this is the pointer to a array which we are allocating to this particular module parameter. And this is usually the usual permissions. And this is the macro by which we can just put the description of different variables of the parameter. And this is a function so like these parameters are accessible in the user space and kernel module. So if we want to keep the names different in the user space and kernel space, at that time, like we can define this name, this is for user and this is for specific for module inside the module. So in this way we can have the different name uh, for the same parameters inside the module and outside of the module. So let's now discuss about the export symbol. So as we have discussed that we are inserting module inside our running kernel. Okay. So like if our module is inserted, it doesn't know which functions are there inside the kernel. So if we want to use the already defined functions inside a kernel, inside our module, at that time we have to use this directive export symbol or export symbol GPL. It tells the kernel that this function is accessible to all the modules. So whatever modules we are inserting or building in a kernel, those modules can use those functions. So if you see here, it is already written here. It tells the KBuild mechanism that the symbol referred to should be part of a global list. When this function is or the variable is part of a global list, then any module can access it directly without any permissions. So if we are like these functions should be used by the other modules, that's why it should not be static. If it is static, then it will be used only that particular kernel code only. So we have to make sure that exported symbols are non-static in nature. So this is an example. If you see here, this is a assume that this is a this is a this this is module 1 or module 2, or you can say this is a already kernel code. So here this function I am defining as export symbol. That means other module can also see it. So if you see here, we can access this function here, and in this file this function is not defined here. So in this way we can say that when we export a symbol, that means we are providing this interface to other modules to use it, and they know that this function is existing somewhere in the already built kernel. So this is all for this video. So in short we can say that in this video we have discussed about the definition of module, and we have also seen how to build a kernel module and load and the how to configure different the module in different way by a config file. And we also have discussed about the module parameters. So this is all for this video. I will see you in the